Problem 21. First, we calculate the total choice of choosing two cards. The first card we have 8 choices. Then the second card will have 7 choices. So that's 8 multiplied 7. Because the order of the two cards does not matter, therefore we divide that by 2. And that's 28 choices. Now, if we would like to choose a winning pair, we can the first one, we still have 8 choices. But for the second card, we can choose from either the other 3 cards of the same color or from another color that has the same labeled letter. So that's 4 choices in total. And again, the order does not matter, so we divide that by 2, and that gives us 16 choices. And so the probability will be 16 divided by 28, and that is 4 out of 7. The answer is D. Problem 22. A lemming sits at a corner of a square with side length 10 meters. We draw a square with side length 10 meters. Assume the lemming sits at corner B. It runs 6.2 meters along a diagonal toward the opposite corner. So 6.2 meters. And then assume the lemming arrives at point E. After that, it stops, makes a 90-degree right turn and runs 2 more meters. And then let's assume it ends at F. Now, what's the distance from this point to all 4 boundaries of the square? We can draw the distance from F. Now we can observe that the distance from F to the opposite sides adds up to 10 meters. And this distance, the sum, also adds up to 10 meters. Therefore, the total distance to the 4 sides will be 10 plus 10 equals 20. And the average will be 20 divided by 4, and that's 5 meters. So the answer is C. To calculate the area of the shaded region, we can assume the center of the grid is O. And let's focus on 1/4 of the grid because it's a symmetric pattern. And assume this point is A, this corner is B, and here it's C. And let's draw lines across AC and OB. And let's assume these points are D, AC and OB cross at D, and then here it's E, and this crossing point is F. Now let's assume the cell in the grid has the boundary as 1. So AB equals BC equals 1. So AC is therefore equals BE equals square root of AB square plus BC square, because AB and BC equals 1, so that's square root of 2. Now, similarly, we can get OF equals BE divided by 2, because it's the diagonal of a cell. That's square root of 2 divided by 2. And then EF also equals BE equals square root of 2. So OD equals OF plus EF plus DE, and that's 2 multiplied square root of 2. So now the area of the shaded area in this section will be OAEC. It equals the triangle OAC subtract triangle AEC, and that is 1/2 AC multiply OD subtract 1/2 of the area of the unit cell, and that's 1. So we know that AC equals square root of 2, and OD equals 2 multiplied square root of 2, subtract 1/2, and that gives us 3/2. And because we have this is 2 in the denominator, because we have 4 of these areas, therefore the total will be 2/3 multiply 4, and that is 6. The answer is B. Problem 24. To choose 3 numbers from the 4 digits to construct a 3-digit number, the total number of choices will be 4 multiply 3 multiply 2, and that is 24. Now let's consider that the 3-digit number must be divisible by 3. If we have 1 in our choice, then the other 2 numbers must be 2 and 3. So in this case, we have 1, 2, 3, and the total number of choices of the arrangement will be 3 multiply 2 multiply 1, and that's 6. Now if we don't have 1 and we have 2 in our choice, then the other 2 numbers will be 3 and 4. In that case, the arrangement of the 3 numbers will also be 3 multiply 2 multiply 1, and that's 6. Therefore, the probability will be 6 plus 6 divided by 24, and that is 1/2. The answer is C. Problem 25. Because the probability of the score is a ratio, so it's not related to the absolute value of the radius of the circles. Therefore, to simplify this problem, we can assume the inner circle has a radius of 1, and the outer circle has a radius of capital R equals 2. Therefore, their proportion is still 2. Now, let's assume the area of where 1 is in the inner circle is A, and the area where 2 is in the outer, between the outer circle and the inner circle is B. Because the area of the circle is pi r squared, so A equals 1/3 pi r squared equals 1/3 pi, and B equals 1/3 pi capital R squared minus A, and that is 4/3 pi subtract 1/3 pi, and that is pi. Therefore, the ratio between B and A is pi over 1/3 pi, and that's 3/1. Therefore, to simplify this problem, we can just assume the 3 areas in the inner circle has area 1, and the 3 areas in the outers between the outer circle and the inner circle has area 3. Now let's assume if the first dart gets to 1, then that's 1 in the inner circle and plus the 2 3s, the area between the outer circle and the inner circle. Divide by the total area, which is 3 3s and 3 1s. Their sum will be 12. It multiplies. If the second dart lands in 2, then result will be odd. So for 2, there are 2 2s in the inner circle, so that's 1. Their area is 1 plus 1, and 1 2 between the outer circle and the inner circle, and the area is 3. Again, divided by the portion of the total area, which is 12. Because we just considered the first dart land in 1 and the second dart land in 2, and their order can switch, so we multiply that by 2. And this is 7/12 multiply 5/12 multiply 2, and that is 35/72. So the answer is B.